Okay, in this problem, we're going to visit this Desmos link, and then we're going to let f of x be x squared, and we're going to let x approach 2, so a equals 2 in this problem. And suppose epsilon is 0.01, we want to determine delta so that if the absolute value of x minus a is less than delta, in other words, the distance between x and a is less than delta, then the distance between f of x and L will be less than epsilon. So I'm going to click on this link. Okay, and we're taken to this screen, which is just a template. And we need to type in our f of x, which is x squared, and our a, which is 2. And then we come up with this picture that gives us the epsilon band for a particular interval around 2, which is a. And we want to come up with a delta value. Remember, delta is the distance between a equals 2 in this case and the edge of this interval down here. It's easier to see if I make it bigger. So delta goes from 2 to this right-hand endpoint, or 2 to this left-hand endpoint. And we want to adjust the delta so that we get epsilon equal to 0.01. To find the interval around 2, such that if we pick an x value in that interval, it will be within epsilon equals 0.01 of the limit value of f of x as x approaches 2, which is, we know is 4, but just think of it as the limit value. Okay, so we want to get epsilon, represented here by e, down to 0.01, and then we'll see what the corresponding d is, which stands for delta. Oop, too far. So pretty close. We could probably get a little bit closer, maybe make this 2, this delta 2. What happens if it's 3? It's a little bit bigger than we need. How about 2.5 will be pretty darn close. So for a delta of 0.0025, we'll be just about within epsilon of the limit. So in other words, okay, we got to zoom in on this over here. If you pick an x value in this interval, then and plug it into the function, you'll be guaranteed that the function value that you get, the output value that you get, will be somewhere in this interval, which is within about epsilon equals 0.01 units of the actual limit. Okay, let's go back and answer the question then. We want to plug in 0.0025. Okay, here we go, 0.0025. And we got the green check mark, so we're good to go.